Good afternoon, students. In the last class, we are discussing about the orbital velocity of an object. That is, usually we consider that as the satellite, right? So today we are going to discuss on energy of an orbiting satellite, right? So here we are going to discuss on the energy of a satellite which is revolving around the planet, right? So in general we taken as the earth as the planet, right? So earth has mass, that is capital ME, where ME is the mass of the earth, and from the center RE is the radius of the earth. So consider one satellite of mass m at a height h from the surface of the earth, right? So now this satellite is moving or revolving around the earth in circular path, right? So then the radius of the satellite becomes re plus h, right? So here we are discussing on the energy of the satellite, that is orbiting satellite. So orbiting satellite is nothing but the satellite which is moving with some velocity. So that velocity is VO, horizontal velocity, that is the orbital velocity that we already discussed in our last class, right? So the object or the satellite will traces the circular path. So the radius of the circular path is RE plus h, right? So now the satellite is moving with the orbital speed, then it possesses the kinetic energy, right? So kinetic energy of an orbiting satellite, that is equals to half mvo square. So mvo is the orbital speed, right? So in the last class we derived the relation for the orbital speed, that is mvo is equals to under square root of, in terms of gravitational constant, that is capital G m e divided by r e plus h. So in the last derivation, we neglected the value of h because that h is very less compared to that of the radius of the earth. So here we are considering at a certain height h. So hence we taken the value is re plus h, right? So now substitute here. So here we have VO square. So hence if we squaring this value, we getting GME divided by re plus h, right? So where m is the mass of the satellite, right? So 1 by 2 small m. So in place of VO square, so square root and square get cancelled. So we can write GME divided by RE plus H, right? So calling this as the first relation. So from the first relation, we observe that the magnitude of the kinetic energy is positive, right? So why we take on the kinetic energy? The satellite is moving with the speed VO. So any object which is moving, then it possesses the kinetic energy, right? So from the formula of the kinetic energy, half m v square, m is the mass of the satellite and VO is the speed of the satellite, right? So in the last class we derived the relation for the orbital velocity. So that is the relation. VO is under square root of GME divided by RE plus H. So substituting here, so square and square root get cancelled. The remaining term is GME divided by RE plus H, right? So this is the kinetic energy, right? So now the object is at a certain height from the surface of the earth. So ಯಾವುದಾದ್ರು object ನಮಗೆ certain height ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ, so that object possesses the potential energy. So from the definition of the potential energy, so object the energy which is possessed due to its position. So position means height, right? So that we call as the gravitational potential energy, right? So from the concept potential energy, that is the gravitational potential energy. So in the previous class also we derived the relation for the gravitational potential energy, that is equals to minus G m E, right? So mass of the earth and to the mass of the satellite divided by, so that object is at a height from the center of the earth, that is Re plus H, right? So this is the relation for the gravitational potential energy. So this relation is also we derived in the previous class, right? So we taken this as the second relation, right? So the total energy of the orbiting satellite, right? So total energy is equals to, so total energy is always equals to sum of kinetic energy plus potential energy, right? So total energy is the sum of kinetic energy plus potential energy. So from equation 1 and 2 we have the kinetic energy and also we have the potential energy. So substituting and simplifying we get the total energy, right? So from this kinetic energy, half GME into small m divided by Re plus H, right? So this is the kinetic energy. So plus into minus, we get minus G m E m divided by Re plus H, right? So in these two terms, in kinetic energy and potential energy, the term GMEM by Re plus H both are same. So we can take common outside or we can take the LCM. So LCM to simplify model and final total energy we are getting minus 1 by 2 GME M divided by Re plus H. So this is what the total energy of orbiting satellite, right? So to find the total energy of the orbiting satellite, first we need to find the kinetic energy. Again from the basic relation, half mv square, m is the mass of the satellite, v is the orbital speed. So ಯಾವ ಸ್ಪೀಡ್ ಅಲ್ಲಿ satellite move ಆಗ್ತಾ ಇದೆ ಅದನ್ನ ನಾವು kinetic energy ಅಂತ ಕರೀತೀವಿ. So the satellite is at a certain height, then it possesses the potential energy. So the magnitude of the kinetic energy is positive, right? So magnitude of the kinetic energy is positive, but the potential energy magnitude is negative, right? So if you observe here, this term is same in relation 1 and 2. So comparing the relation 1 and 2, so kinetic energy is half of that of the potential energy, right? So this is the total potential energy, means kinetic energy ಏನಿರುತ್ತೆ ಅಂದ್ರೆ potential energy ಅಲ್ಲಿ half ಇರುತ್ತೆ, right? So from that we can write the relation kinetic energy is half of the potential. Kinetic energy by potential energy we get 1 by 2, right? So kinetic energy is equals to 1 by 2 times of the potential energy. That means kinetic energy is half of the value of the potential energy, right? So in the final expression, total energy we are getting minus. So what it indicates here, so minus in represent ಮಾಡ್ತಿದ್ದಾರೆ. So minus indicates that the object is in the gravitational pull. So negative sign that indicates the total energy indicates that satellite will not escape away from the gravitational pull. So if this total energy value is positive, then the object will move away from this circular orbit, right? So what it indicates, the negative sign means the object or the satellite will be in the orbiting path. So it is under the gravitational pull. So that is indicated by minus. So ನಮಗೆ final expression ಅಲ್ಲಿ ಏನು ಬರಬೇಕು ಅಂದ್ರೆ minus ಬರಬೇಕು. If in case we get the positive value, means the satellite will not follow the circular path. That means it will not revolve around the planet. So it will escapes away from the orbiting path. So ನಾವು ಈ path ಅಲ್ಲಿ ಅದು rotate ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ so ಈ path ಬಿಟ್ಟು ಅದೇನಾಗುತ್ತೆ ಹೊರಗಡೆ ಹೋಗುತ್ತೆ if the total energy value is positive, right? So total energy of the orbiting satellite is negative, right? So total energy ಯಾವುದಾದ್ರೂ ಒಂದು orbiting satellite ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಅದರ ಎನರ್ಜಿ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ನಮಗೆ ಮೈನಸ್ ಇರುತ್ತೆ. So that indicates, so negative sign indicates, the negative sign indicates the satellite will not escape from the gravitational pull or gravitational force, right? So that indicates for the negative sign, right? So ಇಲ್ಲಿ ಏನು ಇಂಪಾರ್ಟೆನ್ಸ್ ಇದೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಗೆ ಟೋಟಲ್ ಎನರ್ಜಿ ಅಂದ್ರೆ ಯಾವುದಾದ್ರೂ ಆಬ್ಜೆಕ್ಟ್ ನಮಗೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ, ಯಾವುದಾದ್ರೂ ಒಂದು ಪ್ಲಾನೆಟ್ ಅರೌಂಡ್ ಅಂದ್ರೆ ಅದರದ್ದು ಎನರ್ಜಿ ಯಾವಾಗಲೂ ನಮಗೆ ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ಬರ್ತಿದೆ ಅಂದ್ರೆ ಅದ್ರ ಮೀನಿಂಗ್ ಆಬ್ಜೆಕ್ಟ್ ಏನಾಗ್ತಿದೆ ನಮಗೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇದೆ, right? That is in under the gravitational pull. If the energy is positive, ಇಲ್ಲಿ ನಮಗೆ ಬರ್ತಿರೋ ಟೋಟಲ್ ಎನರ್ಜಿ ಪಾಸಿಟಿವ್ ಬಂತು ಅಂದ್ರೆ it will not traces the circular path, so it will move away from the gravitational pull, right? So because energy positive ಇತ್ತು ಅಂದ್ರೆ it has more energy, right? So the kinetic energy is balanced by the potential energy, right? So from the conservation of the energy, so total energy is sum of kinetic energy plus potential energy, right? So ನಮಗೆ kinetic energy ಕಮ್ಮಿ ಆಗ್ತಾ ಹೋದ್ರೆ potential energy ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Same wise, if the kinetic energy is increasing, that is balanced by the potential energy, right? So that is from the conservation of energy. If both are increasing, then the object will move away from the earth's orbit, right? So that is away from the gravitational pull. So gravity, due to gravity in the ಏನಾಗ್ತಿದೆ, it is revolving around the earth, right? So this is the simplest concept on the energy. Now ನಿಮಗೆ basics ಇಷ್ಟೇ mention ಮಾಡಿರೋದು, right? So to obtain the expression for total energy, first we need to find the kinetic energy, right? Then potential energy. So next relation is total energy, that is sum of kinetic energy plus potential energy. We getting the relation, right? So in this we having two concepts. So one is negative sign, which indicates that the object will be revolving around the planet, right? So it will not escape away from the gravitational pull. So that indicates what the negative sign. And the second one is the kinetic energy is always half of the potential energy, right? So kinetic energy ಏನಿದೆ ನಮಗೆ potential energy ಅಲ್ಲಿ half ಇದೆ, right? So these are the two concepts which explained in this topic, right? So this is about the energy of an orbiting satellite, right? So next, artificial satellites. Right. So in the last class also we discussed we have two types of satellites. One is natural satellites and another one is the artificial satellites. Right. Artificial satellites are the man-made satellites. So that we are sent to revolve around the Earth, right? So Earth or other planets, right? So those satellites are the objects which revolving around the Earth by man-made. So now ಏನ್ ಮಾಡಿ ಕಳಿಸಿರ್ತೀವೋ the objects, so that objects we call as the artificial satellite, right? So in artificial satellite we having two types. So one is geostationary satellite and another one is polar right? So these are the two types of the artificial satellites. One is geostationary satellite and another one is polar satellite. So in the name itself, it says that stationary, right? So it appears to be stationary. So now we got the other one satellite and observe that appears, but it is revolving around the Earth, right? So the actually move that satellite is appears type of satellites we call as geostationary satellites. Then polar satellites. So in the name itself, right? So the satellites which are revolving around the Earth in the polar plane, right? So from North Pole to South Pole, these are revolving around the Earth. Then that type of satellites we call as the polar satellites, right? So here only we can difference between the geostationary satellites and polar satellites, right? So the first point is the definition of the geostationary satellite, right? So satellites in a circular path revolving around the earth in equatorial plane, right? So revolving around the earth in equatorial plane. So in satellites ಎಲ್ಲ ಯಾವ plane ಅಲ್ಲಿ revolve ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂದ್ರೆ, so these are revolving around the equatorial plane, right? So if we consider this one as earth, right? So geostationary satellites are revolving along the equatorial plane. So along the equator ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇರುತ್ತೆ, satellites revolve ಆಗ್ತಾ ಇರುತ್ತೆ, right? So these satellites are in the circular path and revolving around the earth in equatorial plane, right? So here in polar satellite, so these are the satellites which revolve around the earth in polar plane, right? So that means polar, that is from north to south pole. So if you consider this is earth, then so satellites are revolving around the earth from north pole to south pole, right? Satellite, right? So this is the path. So North Pole is the South Pole ಕಡೆಗೆ revolve ಆಗ್ತಾ ಇರುತ್ತೆ satellites. So either it may be circular path or it may be elliptical path, right? So here in geostationary satellite, the satellites are revolving in an equatorial plane. That is, along the equator, the satellites are revolving, right? So this is one difference. So geostationary satellites ಏನಾಗ್ತಾ ಅಂದ್ರೆ equatorial line ನಲ್ಲಿ revolve ಆಗುತ್ತೆ. Polar satellites along the poles, that is in the direction from north pole to south pole. So north ಇಂದ south directions ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ಅಂದ್ರೆ satellites revolve ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So here it may be the circular path or it may be the elliptical path. So ಇಲ್ಲಿ ನಮಗೆ circular path ಆದ್ರೂ travel ಆಗಬಹುದು ಅಥವಾ elliptical path ಆದ್ರೂ travel ಆಗಬಹುದು, right? So the next second difference, right? So the second difference is geostationary satellites are placed at a height of 36,000 kilometers, right? So ಎಷ್ಟು height ಅಲ್ಲಿ ಇರುತ್ತೆ from the surface of the earth ಅಂದ್ರೆ 35,800 kilometer, or approximately we take that one as 36,000 kilometer, right? So these satellites are placed at a height of 35,800 kilometer, right? So this height, right? So h value is very greater than the radius of the earth, right? So radius of the earth is just 6,400 kilometer, but geostationary satellites are placed at a height which is very greater than the radius of earth, that is about 35,800 kilometer. Approximately we can take that one as 36,000 kilometer, right? So in polar satellite, so these satellites are placed at a height about 500 kilometer to 800 kilometer, right? So polar satellites height ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ just 500 kilometers to 800 kilometers. So this height is very less compared to that of the radius of the earth. So radius of the earth ನಮಗೆ 6,400 kilometer ಇದೆ, but that height is very greater than that of the polar satellite height. So polar satellite height is just about 500 kilometer to 800 kilometer, right? So the next point is the time period of the revolution of the geostationary satellite is 24 hours, right? So this is equals to the rotation period of the earth, right? So earth rotation, that is revolving around about its own axis, is to time ತಗೊಳುತ್ತೋ. So that time is taken by the geostationary satellite, right? So hence the name is given as geostationary satellite, because अर्थ रिवॉल्व ಆಗ್ತಿರೋ ಟೈಮ್ ಮತ್ತೆ ಸ್ಯಾಟಲೈಟ್ ರಿವಾಲ್ವ್ ಆಗ್ತಾ ಇರೋ ಟೈಮ್ ಎರಡು ಕೂಡ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ಹೆನ್ಸ್ ದೀಸ್ ಸ್ಯಾಟಲೈಟ್ಸ್ ಆರ್ ಅಪಿಯರ್ಸ್ ಟು ಬಿ ಸ್ಟೇಷನರಿ, ರೈಟ್? ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಸ್ಯಾಟಲೈಟ್ ಇಲ್ಲಿ ಅಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಸ್ಯಾಟಲೈಟ್ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಅಟ್ ಈಚ್ ಅಂಡ್ ಎವರಿ ಪಾಯಿಂಟ್ ದ ಸ್ಯಾಟಲೈಟ್ ಲುಕ್ಸ್ ಆರ್ ಅಪಿಯರ್ಸ್ ಟು ರಿಮೈನ್ಸ್ ದ ಕಾನ್ಸ್ಟೆಂಟ್, ದಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಟೈಮ್ ಪೀರಿಯಡ್ ಆಫ್ ದ ಸ್ಯಾಟಲೈಟ್, ರೈಟ್? ಸೊ ಟೈಮ್ ಪೀರಿಯಡ್ ನಮಗೆ 24 ಅವರ್ಸ್ ಇರೋದ್ರಿಂದ ಅರ್ಥ revolve about its own axis ತಗೊಂತಾ ಇರೋ ಟೈಮ್ ಮತ್ತೆ rotation about the earth ತಗೊಂತಾ ಇರೋ ಟೈಮ್ ಎರಡು ಸೇಮ್ ಇರೋದ್ರಿಂದ ಏನಾಗ್ತಿದೆ ನಮಗೆ it appears to be geostationary. So hence the name is given as geostationary satellites, right? So time period of revolution is 24 hours, right? So about its own axis ಅಲ್ಲಿ earth rotate ಆಗೋ ತಗೊಂತಾ ಇರೋ ಟೈಮ್ ಕೂಡ ಎಷ್ಟು 24 hours. That is, we consider that as one day, right? So here it is time period of revolution is 100 minutes, right? So approximately 1.5 hour. Within 1.5 hour, the satellite will cover one revolution around the earth, right? So 1.5 hour ಅಲ್ಲಿ complete ಆಗಿ one revolution ಆಗುತ್ತೆ earth around, right? So this is approximately 100 minutes, right? These are the main differences between the geostationary satellites and polar satellites. So next, the applications, right? So here only we can mention applications of geostationary satellite and applications of polar satellites, right? So that is forecast the changes in atmosphere. Forecast the changes in atmosphere, right? So the next one is to know the shape, and size of Earth, right? So we need to study about the size and shape of the Earth. We are using the geostationary satellites, right? And the third one is to transmit TV program over long distance. So if in case they ask for the 2 marks, mention the applications of artificial satellite. Then you can write any two applications either from geostationary or from polar satellite. So individually, if they ask for the write the applications of geostationary satellite, then you need to write any two. So 2 marks you need to write any two. So 3 marks you need to write any of these three. Right? So you can just chances. So 3 marks difference you can choose any three. So add model, right? So here in applications of polar satellite, so the first application is remote sensing. Forecast, so remote sensing, right? So meteorology. Right? So weather forecast, so here we can make the difference between the geostationary and polar satellite. So it says it appears to be stationary. So polar satellite, they are revolve around the Earth from polar regions. That is from north region to the region, right? So this is basic about the artificial satellite. So important one is it is placed at a height of 35,800 kilometer and it takes 24 hours to revolve around the Earth, right? So that is revolution, time period of revolution, and it is placed at a height. So ನಮಗೆ ಜಿಯೋಸ್ಟೇಷನರಿ ಸ್ಯಾಟಲೈಟ್ಸ್ ನ ಪ್ಲೇಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಇಷ್ಟು ಹೈಟ್ ಅಲ್ಲೇ ಪ್ಲೇಸ್ ಮಾಡಬೇಕು ಅಂತ ಯಾವ ರಿಲೇಷನ್ ಅಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಅಗೈನ್ ಫ್ರಮ್ ದ ರಿಲೇಷನ್ ಟೈಮ್ ಪೀರಿಯಡ್ ರಿಲೇಷನ್. ಇನ್ ದ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ ಅಬೌಟ್ ದ ರಿಲೇಷನ್ ದಟ್ ಈಸ್ t is equals to 2 pi under root of re by g, right? So here we need the value of h so that we can write re plus h, right? So squaring and simplifying we get the relation for the h, right? So h is to place ಅಲ್ಲಿ ಇರಬೇಕು ನಮಗೆ t24 substitute ಮಾಡಿದ್ರೆ we can get the value of h, right? So that value is 35,800 kilometers. So in this T we know that is 24 hours. So geostationary satellite irbekandre the time period is irbeku 24 because the earth revolving about its axis estide namge 24 hours. So hence we know the value of T. So all other remaining 2 pi is a constant, G is constant, Re is constant. So all substitute and simplify we get the value of H and that value is 35,800 kilometer, right? So this is about the satellites, that is artificial satellite. So on the last topic of this chapter, that is weightlessness. So ಇದನ್ನ ನಾವು already laws of motion ಅಲ್ಲಿ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ by solving the problem, right? So here also weightlessness, nothing but it has no weight, right? So that is the state of having or appearing to have or to have no weight, right? So weight is nothing but mass into acceleration due to gravity. So every body having some mass. So ನೀವು ಯಾವುದೇ ಆಬ್ಜೆಕ್ಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಏನಿರುತ್ತೆ ನಮಗೆ ಮಾಸ್ ಇರುತ್ತೆ. So that mass we can measure as weight, right? So mass ಬೇರೆ weight ಬೇರೆ. So mass is a scalar quantity, weight is a vector quantity, right? So mass has only the magnitude, right? So mass is directly we can defined by using the numerical value. So weight mass of an object is 10 kg. That means only it indicates the mass of that object. It has only the magnitude along with its SI unit. Hence mass is a scalar quantity. Weight, so weight is always acting towards the center of the earth. That is because of due to the acceleration due to gravity, right? So mass ಮತ್ತೆ weight ಎರಡು difference ಇದೆ. Mass is a scalar, weight is a vector, right? So weight is equals to m into g, right? So weight is a vector, so this is always acting towards the center of the earth. Why? Because acceleration due to gravity is always acting towards the center of the earth, right? So every object having the mass, so hence m is not equals to 0, right? So all objects ku namge ಏನಿದೆ mass ಇದೆ, so hence we can't take any object without mass, right? So but here what it states means the state of having or appearing, right? So namge weight ಯಾವ ತರ appear ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ weight of an object is 0, but it will never happen, right? So weight na 0 ಅಂತ ನಾವು ತಗೊಳಕ್ ಬರೋದಿಲ್ಲ. Why? Because every object having the mass, so m is not equals to also a constant, so that value is 9.8. So both having the value ಇರೋದ್ರಿಂದ ನಮಗೆ weight ಏನಾಗುತ್ತೆ, weight is also getting some value, but the weight is not actually equals to 0, right? So here weightlessness, but it appears to be weightless. So ನಮಗೆ ಅನ್ಸುತ್ತೆ, that means we are getting feeling is 0, right? So that we call as the weightlessness. So that we are going to study in two cases. So where we are observing the weightlessness, right? So actually ನಮಗೆ weight ಇರುತ್ತೆ, but ನಮಗೆ ಫೀಲ್ ಆಗ್ತಾ ಇರೋದು ಅಥವಾ ನಮಗೆ ಅನಿಸ್ತಾ ಇರೋದು ಏನು ಅಂದ್ರೆ we having no weight. So that is we state that state of having or appearing to have no weight. So no weight is nothing but w is equals to 0. W is equals to 0, so that weight we call as apparent weight. So namge true weight irutte. For example, if we consider this object which having the mass 10 kg, then this weight is acting vertically downward, so hence 10 into 9.8, so its weight is 98 Newton, right? So this weight we call as true weight, right? So namge true weight ಎಷ್ಟಿದೆ 98 Newton ಇದೆ, right? So here we having the numerical value that is 98. So in some cases we feel or we sense that the weight of the object is 0, right? So this type of weight we call as apparent weight, or also we call as false weight, right? So where we are observing the apparent weight or weightlessness, right? So weightlessness na ನಾವು ಎಲ್ಲೆಲ್ಲ observe ಮಾಡ್ತೀವಿ ಅದನ್ನ two cases ಅಲ್ಲಿ study ಮಾಡೋದು. One is when freely falling lift. So lift ಅಲ್ಲಿ ನಾವು free fall ಆಗ್ತಾ ಇದ್ದಾಗ there we are observing the concept or the phenomenon that is the weightlessness, right? So case 1, when a person in a freely falling lift, right? So in the first case, so here we are observing the phenomenon that is weightlessness, right? So consider one weight lift. So we will do walls, right? So here we have the lift, right? So this is lift, right? So inside lift, one person is standing, right? So lift is moving vertically downward, so its acceleration is in the downward direction, right? So now person has some weight, right? So person weight ಯಾವ ಕಡೆ act ಆಗ್ತದೆ towards downwards. So again from the free body diagram, right? So from FBD. So ಇದನ್ನ ನಾವೆಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಲಾಸ್ ಆಫ್ ಮೋಷನ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. That is free body diagram, right? So mass is, so person is another person has some mass, right? So his weight is acting vertically downward, so that is mg, right? So now the lift will exert the equal and opposite force onto the person, so that is the normal, right? N, right? So the now lift is moving vertically downward direction. So from the free body diagram, so we can write the relation mg minus n, that is equals to m into a, right? So we need the normal force n, that is equals to mg minus ma, right? So n is equals to, we can take m common, g minus a, right? Person, right? So here w is the weight of the person, that is the true weight, right? So here the condition is freely falling. So normal acceleration ಅಲ್ಲಿ lift move ಆಗ್ತಾ ಇತ್ತು. For example, acceleration is some 2 meter per second, right? So one example ಸಮೇತ ನಾನು explain ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So lift is moving with some 2 meter per second square, and mass of the object, mass of the person, we can take m is equals to some 30 kg, right? So from this g is 9.8. So if we substitute here n is equals to 30 into, so round off we can take 10 minus 2. So this is what n, right? So n is the normal reaction, that means opposite force which is exerted by the lift on the person. So that means n value is discussing the weightlessness. The condition is freely falling. So freely falling, the object will fall freely. That means the object is moving with the acceleration due to gravity. That means a value is how much? G, right? So this is the condition for the freely falling. So freely falling on the ಹೇಳ್ತಿದಂಗೆ its initial velocity is 0 and it moves with an acceleration g. So ಇದನ್ನ ನಾವು motion in a straight line ಮತ್ತೆ motion in a plane ಎರಡು ಕಡೆನೂ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ. While we are solving the problems freely falling, then the object initial velocity is 0 and moving with the acceleration g. That means a is equals to g. So now substitute in this relation, right? A value ಗೆ g substitute ಮಾಡಿದ್ರೆ n is equals to m into g minus g. So g minus g is 0, so 0 into m is 0, so that means n is equals to 0, right? So here n value is 0, but the weight is mg. So downward ಏನ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೋ upward ಕೂಡ ಅಷ್ಟೇ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರಬೇಕು ತಾನೆ. So normal 0 ಬರ್ತಿದೆ ಅಂದ್ರೆ weight ಕೂಡ ಏನಾಗಬೇಕು ನಮಗೆ 0 ಆಗಬೇಕು. That means the condition is w upper end, right? So that is equals to 0. So this is the condition for the weightlessness, right? So ಇದನ್ನ ನಾವು mathematically prove ಮಾಡಿದೀವಿ, right? So n is equals to mg when it is stationary, right? So ಇದನ್ನ ನಾವು laws of motion ಅಲ್ಲಿ free body diagrams ಅಲ್ಲಿ discuss ಮಾಡಿದೀವಿ. When the lift is moving with the acceleration due to gravity g, then n is equals to 0. So n is equals to 0 ಅಂದ್ರೆ w is equals to 0. But ನಮಗೆ true weight ಏನಿದೆ mg ಇದೆ. So mg 0 ಆಗೋ ಚಾನ್ಸ್ ಇಲ್ಲ. So that weight is appears to be 0. So that's why we taken that as w upper end, right? So that is the upper end weight, right? So this is the condition for the weightlessness, right? So on the second one, case 2, right? So a person in a satellite, orbiting near the Earth surface, right? right? So this one is the second case. So in second case a person in the satellite. So person in a satellite experiences the weightlessness, right? So satellite ಅಲ್ಲಿ ಇದ್ದವರಿಗೆ ಯಾವುದೇ ತರ weight ಇದೀನಿ ಅಂತ feel ಆಗೋದಿಲ್ಲ. So that case we are studying. So this is the R, right? So this is the satellite. So inside the satellite a person is there, right? So satellite ಒಳಗಡೆ ಒಬ್ಬ person ಇದ್ದಾನೆ. So it is nearer to the surface. So nearer to the surface ಅಂದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ, RE is very greater than H. So nearer to the surface ಇರೋದ್ರಿಂದ we can neglect the H, right? So this satellite is moving with the speed that is the orbital speed. So satellite ಏನಾಗ್ತಾ ಇದೆ ನಮಗೆ orbital speed ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. So from this relation VO is equals to under square root of GME divided by RE, right? So that is the orbital speed of a satellite. So that we derived in our last class, right? So the object is moving in a circular path, so hence it experiences the centripetal force. So as it is experienced by the centripetal force, so it has the centripetal acceleration, right? So from the relation centripetal acceleration AC, that is equals to V naught square divided by RE, right? That is again from the chapter motion in a plane. So we derive the relation acceleration, centripetal acceleration is equals to V square divided by R. So here R is the radius of the earth, so hence we take a RE. So from the relation VO we have root of GME divided by RE. So here we have VO square, so square and square root get cancelled. So from this we can write GME divided by RE, right? So RE in the denominator also we have RE, so RE we get RE square, right? So we can replace this value by AC is equals to G. Why? Because the relation between acceleration due to gravity and due to the gravitational constant, G is equals to GME divided by RE, right? So now the centripetal acceleration is equals to G. Now the person who is inside the satellite, so again his weight is always acting towards the center of the earth. That's why mg minus normal n, that is equals to mac, where mac is the centripetal acceleration. So again from the free body diagram, so from this we can write n is equals to mg minus mac, right? So n is equals to m into g minus AC. So here already we derived the relation AC is equals to G. So substituting AC is equals to G. So G minus G 0. So 0 into M, that is 0. So N is equals to 0. That is because AC is equals to G. Right? So now N is equals to 0. That means weight. So that weight we call as apparent weight. So this is again the condition for the weightlessness, right? So in these two cases we are observing the weightlessness. That means ನಮಗೆ ಸ್ವಲ್ಪ weight ಇರುತ್ತೆ. So weight ಇದ್ರೂ ಕೂಡ ನಮಗೆ ಆ ಸ್ಟೇಜ್ ಅಲ್ಲಿ, so freely falling lift ಅಲ್ಲಿ ಇದ್ದಾಗ ನಮಗೆ weight ಇಲ್ಲ ಅಂತ ಫೀಲ್ ಆಗುತ್ತೆ. So same ways satellites ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ ನಮಗೆ weight ಇಲ್ಲ ಅಂತಾನೆ ಫೀಲ್ ಆಗುತ್ತೆ. So hence they can easily float in the satellite. So ನೀವು observe ಮಾಡಿರ್ತೀರಾ, ಅವರು float ಆಗ್ತಾ ಇರ್ತಾರೆ because ಅಲ್ಲಿ ಅವರಿಗೆ ಯಾವುದೇ ತರಹದ weight sense ಆಗ್ತಾ ಇರೋದಿಲ್ಲ, right? So these are the two cases for the study of weightlessness, right? So ನಿಮಗೆ technically mathematical relation ಏನು ಇಲ್ಲ, just theoretically ಹೇಳಿದಾರೆ ಅಷ್ಟೇ, but this will help for your exams, right? So weightlessness ಅಂದ ತಕ್ಷಣ ಏನು ಅಂದ್ರೆ it appears to be 0, weight is 0. So ಅದು true weight ಅಲ್ಲ, apparent weight. So ಅದು ಕೂಡ ನಿಮಗೆ ನೆನಪಲ್ಲಿ ಇರಬೇಕು, true weight ಚಾನ್ಸ್ ಇರಲ್ಲ. ಸೊ 0 ಆಯ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವೇನು ಅಂತ ಕರಿತೀವಿ, apparent weight ಅಂತ ಕರಿತೀವಿ. Hence W suffix ಅಲ್ಲಿ apparent ಗೆ APP, or we call that one as false weight. apparent weight or false weight, right? So ಎರಡು ಬೇರೆ ಬೇರೆ cases. So ಎರಡರದ್ದು ಬೇರೆ ಬೇರೆ. So exerts equal and opposite forces. So downward S force, upward force act ಆಗುತ್ತೆ, right? This is all about the theory concepts on the chapter gravitation. So it is two theory concept. So ಕೆಲವು ಟಾಪಿಕ್ಸ್ ನ ಡಿಲೀಟ್ ಮಾಡಿದ್ದಾರೆ, that is Kepler's law ಮತ್ತೆ acceleration due to gravity. So acceleration due to ಇಲ್ಲಿವರೆಗೂ up to now we are discussing on the topic, right? So main concept na delete madidare, but even I explained and derived the relation and we continue up to here, right? So in the next classes we will go through all the numericals on each topic related to this chapter, right? Thank you.